Okay, today we're going to go through significant figures. And we're going to add some calculation with it, but first of all you have to know what a significant figure is, or what significant figures are. Well, first of all you have to have some kind of definition or some guidance in order to figure that out. My only role is the non-zero number and everything after it count except trailing zeros. I think we'll go with that. I think that's correct. Okay, so once you have that definition, everything's all nice, but it doesn't really tell you how to count them. So let's say, first of all, we figure out what a trailing zero is. Well, those are ending zeros. No decimal. And that means anywhere in your number. So let's say I have this number. Well, we look at these things, we start counting. I'm going to go through the process of it. Well, there's my non-zero number. So I go 1, 2. These ending zeros have no decimal point. So the only two numbers I'm going to count are here. So this is called two significant figures. What if I want to make them count or change it to a different number? Well, let's say I want to put the decimal here. Well, ending zeros with no decimal is qualified as this. This is no longer that. That guy here makes them all count. So instead of having two significant figures, I just made it so we have 5 significant figures. I just call them sig figs. Does it really matter where I put the decimal point? Not really. Let's say I put the decimal point here. Made it into a decimal, an actual decimal. Well, this one right here makes them all count. 5 significant figures. Now we know not all of my numbers are going to look like this. So let's go ahead and erase these and go with this type of number. Let's say I have something that goes 0.00052. Well, again, the rule, the non-zero number and everything after it count. That's my non-zero number. It's not a zero. So I start counting here. I have 2 significant figures. Well, let's say I change this out. Go 0.0005200. Well, it's the same rule. I can't start counting until I hit the 5, and I have to count all those numbers after it because of this decimal point. So those are not trailing zeros after the 5, 2. They're actually countable. I have 4. This is called 4 sig figs, or 4 significant figures. Now, does it really change as far as my significant figures if I move this decimal point somewhere? Not really. It's the same sig figs. Now, are those all the numbers that kind of look like that? Well, no. We also have something a little bit different. It's called scientific notation. So let's say I have a number that looks like this. And you're going to say, well, got a lot of zeros, so I'm going to have to count them. Sig fig wise, this doesn't make any difference. The only thing I'm going to look at is this. So I see a decimal, every single one of these has to count. So this is actually going to be 4 sig figs, or significant figures. Just remember that when we're using scientific notation, the decimal goes after the first non-zero number. Let's say I have a negative exponent. Well, you're going to notice that since we want consistency, our numbers are going to look the same as far as where the decimal point is in scientific notation. If you see it some other way, it's not written correctly. So here I have how many numbers? Well, I got a decimal. Don't really pay attention to that. We have 3 sig figs. Now remember, we're not really changing the value here. That times 10 to the 18th is still there if you're ever calculating. Now let's go ahead and do some math with it. Well, it kind of goes into steps, and you have to pay attention to all your numbers. Let's go something a little bit easier right now. Let's go, let's say 7 times 3. Well, if we're talking math-wise, well, this is going to be your answer for math. It's going to be 21. In chemistry, that doesn't work because we want our numbers to be very specific. These are kind of general. So if I'm counting my sig figs here, I've got 1 sig fig here and 1 sig fig here. The rule of thumb as far as chemistry is you round to your lowest number of significant figures, which is going to be 1 or 1. Doesn't matter. Then you go over here and you say, well, what's my first significant figure? Well, it's 2. What do I have to put in the end in order to make it 1 significant figure? A trailing 0. Because now it makes it 20, which is my chemistry answer. Now some of you guys may say, well, what if I start messing around with the decimal points here? Okay, well, we're going to use those same numbers. I'm going to spread it out a little bit. Let's say I put a 0 here. Well, is my answer going to change for the chemistry answer? I know the math is still the same. I've got 2 sig figs here. How many sig figs do I have here? Well, I have 1 sig fig. Again, that's the least specific number. That's my rounding. That's still my answer. And it doesn't really change. Sometimes you're going to have to put it on the calculator, but you're still counting and everything. You just need to know how to round it. Let's say I want to change it so it is actually the math answer. So how am I going to change it to get to the math answer? Well, there's 2 options. I can make this 3.0. Now I have 2 sig figs. So now what happens? Well, now it's math and chemistry answers are the same. Let's say I add a 0 to the end here. Now I have 3 sig figs. Well, guess what? That answer is still the same because this is the least number of significant figures. Now let's say we just go ahead and do a large equation. Well, you don't have to do a whole lot of thought. You just use a calculator. So let's go with a little bit larger number. Let's go with 2800, and we're going to times it by 0.0025. Well, first of all, we can look at our sig figs. Trailing zeros don't count, so this is going to be 2 sig figs. We don't start counting until when I hit the 2 and the 5. That one's 2 sig figs. The only difference between that and what we just did is now we have to use a calculator, because we don't want to be spending forever trying to get an answer for that, unless you have a whole lot of time. I started doing that and my answer comes out as actually 7, which is a unique circumstance. We got to make sure that our number's in 2 sig figs. Now we can do things in order to tweak it in order to make it 2 sig figs. We can put a 0.0 and now it's in 2 sig figs. Let's go ahead and do another one. I'm going to make sure that one doesn't turn out the same. So let's say we got 0.00581 times 0.0008928. Now we can do the same thing, look at our significant figures. We don't start counting until we hit the 5. So we got 3 here. Those don't count. 3 sig figs. And then we don't start counting until we hit the 8. That's 4 sig figs. So when I'm calculating, that's my least specific one, or the more general one. This one on the right is more specific. So we go 0.00581 times 0.0008928. Now the calculator I use is looking like this. That is also how you have to enter it in the calculator, the ones we use. But this also means this. Now we also have to pay attention to my 3 sig figs, so all I have to do is start counting. 1, 2, 3. So I'm looking at the 7, deciding what happens to the 8. It becomes 5.19, and then again, exponent still stays there. It's not counted for sig figs, so that would be your answer. Let's go one more. And I'm going to kind of show you a variation of what you could do. So let's say I have this. Times 18,000.0. And you have a number that looks like this. I know some of you guys can probably calculate this without a calculator, which is fine. Let's go ahead and count our significant figures first. This one, that makes them all count. We have 6 sig figs. This one, that decimal makes them all count. That would be 7 sig figs. We have to round to 6 because, again, it's our lowest one. So we're going to go 3, 6, 1, 2, 3, and then add 4 more. Then you say, well, wait, we're supposed to round to 6 significant figures. This number only has 2. Well, there's 2 ways to deal with that. First of all, we can go to the bar. So we're going to go count 1, 2, 3, 4, 5, 6. And we put a bar there, and that bar just indicates I want that to count. And we would count from here to here, because these are actually referred to as embedded zeros. but there is another way to take care of that. We can also change it to scientific notation. So this would be 3.60000 times 10 to the third. That would also be the same answer. No, it wouldn't be times the third. Oops. I'd have to move from here all the way down to the end. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the 8th. Since I have that decimal with the exponent, it makes them all count for 6 significant figures.